Okay, so this is just another video on propagation of error. This one I'm just going to generalize things a little bit more. So let's say, for example, I've got the same A that I had in the last one. Now I've got a different one, B. Okay. So what's the error for adding the two of these? Well, if I back one on top of the other, and by the looks of things, I forgot to label this one as B. So there's B. So one of them is 25.3 plus or minus 0.5 centimeters. That's A. But B is 17.8, and the error is slightly less on the measurement B. So again, if we follow that same idea that we did in the last one, if we look at what's the maximum length that it could be, well, the maximum length of A is the average length that we calculated, which is 25.3 plus the 0.5, which is the error in that calculation. The maximum length it could be is 25.8, just like in the last example. Maximum length of B is slightly less, okay, so it was 17.8, and we've only got 0.3 centimeters of error in this one. So the maximum length of this one could be is 18.1. So if you work out the total maximum, it works out to be 43.8 centimeters, okay? Again, if we do the same thing for the minimum, and you subtract the error from the average this time, then you wind up with 24.8, same as the last one. And this one for B is 17.8, take away 0.3 centimeters, which is 17.5 centimeters. So that's the minimum value that it could be, is 42.3 centimeters, okay? So again, if I do the same idea, that same trick, I take the maximum, I take the minimum, I'm going to split my difference, and then just say that that's the error plus or minus half of it. So you wind up with an error of 1.6 over 2, which is 0.8 plus or minus, okay? And again, I ask that same question, is there a quicker way of doing this? So exactly what you'd expect. Basically what we wind up doing is adding those errors, okay? And again, if we compare with the minimum and the maximum, the average is right in the middle, okay? It's right in the middle. If I take 0.8 from it, I get 42.3, which is exactly what I had above for the minimum. And if I add 0.8 to it, then I get the other value, which is 43.9, again, which I had got the long way, okay? So in general, and here's where I'm going to generalize this, for problems with addition, you'll see this written in the textbooks, but I think it looks quite confusing when it happens, okay? So if Q is some quantity, let me explain what this means. If Q is some quantity that is made up of the value A plus the value B, okay? And if A and B both have errors attached to them, then the error in Q, that's what the delta Q means, okay? The error in Q is the sum of the error in A plus the error in B. So basically, you add the errors. And here's the bit that people often don't get, is the subtraction version of it, okay? So subtraction, let's say, for example, Q is now A, but it's minus B, okay? A take away B. Well, if you look at the rule says that the error in Q is equal to the error in A, not minus, but plus the error in B, okay? Plus the error in B. And let me just explain that just a tiny bit more. Okay, so to explain the subtraction part, if we were to apply the same logic, the exact same logic to how we worked it out, then you'd take the maximum length of A, the maximum length of B, subtract the difference, and you'd see that you get subtract the two values, and you'd get 7.7 centimeters, okay? And then if you did the same thing for the minimum length of A, minimum length of B, you get 7.3 centimeters, okay? Now if you notice, the difference between these two errors is actually not very much, okay? It's only 0.4 centimeters. That can't be right, because the rule says that when we're subtracting our quantities, we still add the errors. There must be a reason as to why that is. And of course there is, and it has to be grounded in logic, and it is. And the reason being is that if you have the maximum length of both of them, then that's not the worst case scenario. It's not the worst case scenario for error at all. Okay, if you can imagine that, let's say the length of A is this pen and the length of B is this pen. Well, the worst case scenario is that this one was actually the longest possible. So let's say 25.8. And this one turned out to be the shortest possible length, which would have been 17.5. Okay, so if I take the maximum, so the worst case scenario, I would use this figure here and this figure here. Okay, so I'll do that over here on the side. So where A is maximum, I've got 25.8 centimeters, and where B is minimum, then I've got 17.5 centimeters. And now if you subtract the difference between those two, you get 8.3. And now if we just ask ourselves, how does that compare to our average figure? Okay, so the average figure was the reported figure that we had at the start. A was supposed to be on average 25.3 centimeters long, and B was supposed to be 17.8 centimeters long. So when you subtract the two of those, you get 7.5 centimeters. Okay, but you can see that this one is a lot more off. Okay, it's a lot more off than than the other ones gave us. Okay, so that means that that's our error. That's our possible error that we could have. Okay, so that means the error for this one is plus or minus 0.8. So just to remind you again of our rule, where Q is some quantity that is made up of, or the sum of, A minus B, you still have to add those errors. Okay, so I hope that makes sense. I'll put up a couple of questions at the bottom of this. Please give